I hope you really enjoyed writing your first assembly code. Now we move on to the second project, and this one is switch red on. Like the name implies, there is a switch involved. So this is an increment over project one, and we would press switch 1 on the microcontroller board to turn on the red LED rather than keeping it on all the time. We would have to press switch 1 and keep it on. So you see, we are moving in a step-by-step manner so that you understand the foundations, because the foundations are really relevant. So for this, we would have to learn new opcodes. So far, we've looked at the move code, we've looked at the load, we've looked at store, and we used it in our program. We've looked at BL, we've seen the BXLR, and we've seen the no operation. So we would have to add more in order to use the switch in our program. So let's look at the new ones. So we have opcode number 8, CMP. This is compare, and what this one does is it subtracts the value of the second operand from the first. Let's take a look at an example. Let's say we have CMP R0 number 1. It compares the value of R0 with number 1, and how it does this comparison, how it knows whether one is greater than the other, is through subtraction. And there is the BEQ, and what this one means is branch if equal to 0. BEQ, mostly used with a CMP instruction. So as we said, the CMP compares by means of subtraction. After it's performed the subtraction and the result it comes up with is 0, then we can invoke B and Q to do something else. For example, let's say we have our previous example here, CMP R0 number 1, BEQ LED1. What this implies is if you compare R0 to the number 1 and it's equal, branch to LED1, and we can think of LED1 as a subroutine somewhere. Compare the value of R0 branch to LED1 if result equals 0. Yes. And we have our opcode number 10. Wow, we know 10 opcodes now, and trust me, there's a lot you can do with these opcodes alone. They are the fundamentals, and you have to understand them and know how to use them, and I'm glad you do. I hope you do. I trust you. We have the BNE, and the BNE branch if Z flag is not set, meaning it's not 0. And you know the Z flag is the 0 flag. So if the 0 flag is not set, branch, which means you can think of this as the opposite of the BEQ. The BEQ said branch if it's equal to 0, and the BNE says branch if it's not 0. Exclamation sign in programming implies not. So if you see exclamation 0, meaning not 0, branch if not 0. So that's the opposite of the BEQ. Let's see this example. We have delay. Let's take this subroutine called delay. And what delay does is, first, it loads 1 second. 1 second you can think of as a variable into R0, and then it subtracts the value 1 from R0. And I'm sure you have noticed here we have R0, R01. Yes, it's like we have 3 operands in the Cortex-M instruction set. You can use 2 operands and 3 operands sometimes. In fact, we can delete this R0. What this R0 is basically doing is that subtract 1 from R0 and put the value back into R0. So it's like R0 equals to R0 minus 1. That's what it means here. This sub SUBS R0, R01. Subtract 1 from R0, put it back in. And this is a subroutine called delay. And we said BNE delay. BNE back to the same subroutine. Meaning if it's not 0, come back here. So you can see this is some sort of a countdown. You have a value 1 second, and 1 second could be as large as, let's say, the number 6 million. Keep in mind BNE is the opposite of the BEQ branch if it's equal to 0. That's BEQ, and BNE branch if not equal to 0. Yes. I'm glad you understand. Remember, C flag is the zero flag. It is set when C equals to 0 and not set when C is any other number. So when we subtracting any other number, it would continue doing it until C equals 0. That's elegant. Let's see number 11, opcode number 11. We have the SUBS, the subs. We just looked at it. Subtract and set flag in APSR. Yes, there's an interesting one. We could use SUBS and SUB without the S. They both mean subtract. But when you have the S after this, it means update or set the flags in the APSR. Remember, we dealt with the APSR. And you know the APSR have flags like the 0 flag, the carry flag, and so on and so forth. So if we were just doing a subtraction and we wanted the answer, we didn't want to use the outcome for something else, we could have used SUB without the S. But we want to set the flag to compare with something else. We want the outcome to be used in a comparison. So we put the S here, and what the S does is it sets the APSR flag. And remember the APSR. Let's take a look at this example. Let's say R0 equals R0 minus R1. Yes, we dealt with this, remember? This one sets the flag here, and there's a visual aid of the APSR. So what this would do is it would set the 0 flag and tell us, or it would set the negative flag as well, depending on the outcome. At every level of this, these flags here are changed because we put this S here. Yes, the S implies set APSR flags. And you would see when we go into more projects, you would see we might have add plus S here, meaning add, and then update the APSR flag. So when you see an S after an instruction, it implies updates the APSR, which means the flags, these flags here.